Passage 3 is not a conflicting viewpoints, so we'll go straight into the questions. Consider the volume of gas collected in trial in experiment 2, so we're going to look at experiment 2, at Ni at 30 degrees Celsius. So Ni is the square, and we want at 30 degrees Celsius. So 30 degrees Celsius, and we want the square. This is the location we're looking at. That volume is coming over here, is about 129-ish. The same approximate volume of gas was collected in trial in experiment 1 for what of Ni? So going back to experiment 1, we want about 129, and we still want the square, the open square. So go to 129-ish about here, and then go over to the square, and it looks about 0.30 grams, so that's going to be H. Question 15. How many temperatures were tested in experiment 1 and how many temperatures were tested in experiment 2? So if we look at experiment, I'm just going to look at experiment 2. We either have 1 or 5. So experiment 2, I can see there's a temperature tested at 10. I have data here. At 20, at 30, at 40, and at 50. So I see that there's 5 at experiment 2. So I know this one is gone and this one's gone. So A and C are both gone. Now I can look at experiment 1. I don't have anything on the X or the Y axis about temperature. So experiment 1, it says, was tested at 30 degrees Celsius only. So only one temperature for experiment 1. So the answer for 15 is B. Which of the following statements describes a difference between experiment 1 and experiment 2? In experiment 1, okay, so let's go through this. Only Fe was tested. Fe, Ni, and Za were tested. So these two go together. Same mass value or the multiple mass values in experiment 1. So these two things go together. All right, so in experiment 1, only Fe was tested. So we can see that Fe, Ni, and Za were both, all three tested in experiment 1. Experiment 2, all three of them were tested. So we know F and G are gone. For H and J, so in experiment 1, it says the same mass value of each metal was tested, but in experiment 2, multiple mass values were tested. Or is it multiple mass values in experiment 1, but in experiment 2, the same mass value of each metal was tested? So if we're looking at this at a selected mass, so we have different masses on experiment 1. So multiple masses on experiment 1 were tested. But in experiment 2, it says was only 30.30 grams, so we only have one mass. So J is going to be the correct answer because H says that the same mass was in experiment 1, but in experiment 1 we had different masses, so that's automatically gone. So the answer is J. Question 17, which of the following variables remain constant throughout both experiments? So constant. So if we look at our charts, temperature did not remain constant because we are changing those. So temperature is gone, so C is gone. Mass of the metal, well again, we have on the x-axis, the mass here was changing on the experiment 1. On the y-axis, we have the volume, so that's going to be changing, so that's not going to stay constant. So the only one left without even looking at anything else is A, the atmospheric pressure. And coming over to the information, if I see anything about atmospheric pressure, going to scan, scan, scan. The atmospheric pressure was all of that for all three steps. So that means that it remained constant. So that one is correct. A is the correct answer. Question 18. If a temperature of 5 degrees Celsius had been tested in experiment 2, would the volume of gas collected for Zn be more likely have been greater than 107 milliliters or less than? So if we go to experiment 2 and we go to Zn, which is the triangle, the open triangle, and we wanted it at 5 degrees Celsius, so that's going to be down here. We can see that this is going to continue going lower. So this was at 107 right now. So it's going to be lower than 107 as it goes down. So we're going to say it's not greater than 107, not greater than 107. It's going to both of them be less. Because for a given metal, the volume of collected gas decreased as the temperature decreased. So as the temperature decreases, going down in temperature, the gas is also going down. That is correct. J says the volume of collected gas decreased. So as this goes down, then the temperature went up. So that is not what's happening, because as the temperature goes up, the volume also goes up. So J is incorrect. H has to be the correct answer. Question 19. Consider the balanced chemical equation in the passage. Based on this equation, if 10 moles of HCl are consumed, how many moles of H2 are produced? So if we come over here to HCl, we already have 2. We need to make that to a 10, so I'm going to multiply that by 5 because it has to be balanced. I have to see what happens with the H2. I also have to multiply this by 5 because I have to balance it. So I'll have 10 HCl's and I'll have 5 H2's. So the answer is A. Last question of the passage. Suppose that the trial in experiment 1 with 0.25 g of Zn is repeated, except that the inverted gradual cylinder is replaced by inverted test tubes, each completely filled with 60 milliliters of water. So we're going to look at experiment 1, the 0.25 g of zinc. Based on figure 1, how many test tubes will be needed to collect all the gas? So we need to collect the gas. We need to know the gas. So going back to experiment 1 with 0.25 g of Zn, so that's going to be the triangle, that is about 95 volume of gas. And it says that each tube will have 60 milliliters of water. So I'll have one will be 60, but I need to still get to 95, so I have to have another 60 to be able to contain all 95. So I have 2 test tubes that would have to be used. So the answer would be G.